How's it going? Today we're going to talk about area. Probably one of the most applicable topics in geometry. Everyone at some point in their life is going to need to find area. Maybe like the area of this wall if we wanted to paint it, or the area of the floor if we wanted to figure out how much carpet we needed, or maybe the area of the ceiling if we wanted to put these ceiling tiles on there. So area is a very useful tool. Area comes in all different shapes and sizes. We've got lots of rectangles, of course. We have other shapes, parallelograms and things like that. Up here we've got this roof tile that's different shapes, things like that. And so we need to be able to find the area of different shapes, break them up, and figure out computations to find area. So let's do some reviewing here about some simple shapes you probably have experience with, and then we'll dig into some more complicated shapes later on. So if we go way back, first we need to define what area is. And let's make sure we understand that area is the space inside a plane figure. And by plane figure, we mean two-dimensional, all right? So 2D, flat, all right? So that space, we can have a funny-looking shape like this, or we can have a nice-looking shape like a rectangle. And we want to find the space inside. And so we define that by the number of squares inside, all right? So for a square, well, if the square is S by S, if the length of the side is S, then it's just S squared, right? Okay? Because if we break this up into a certain number of squares, okay, maybe 1, 2, maybe it's a 5 by 5 or something like that, all right? We could count all the individual squares, all right? Or we could just know that there's 5 by 5 if that was the number, whatever there is, okay? So S squared, and so we can find areas pretty easy, right? 7.2 squared. We're not going to necessarily do all of these, but just a couple examples. Here we get 51.84, and we need units. Units are real important. The units are square yards, all right? So that's how many squares. If we were to break this up into 7.2, I don't think I could draw it exactly, but okay, there'd be 7.2 little squares in here. Okay, so we can write that as yards to the second power, or sometimes we write that as SQR. We can abbreviate it as SQR, yards, okay? That's another way to write it, or we could just write it out square yards. All right, kind of some common ways to do that, okay? So that's the idea. Again, just multiply them up. Okay, try this one, maybe pause and try that. Area, we're gonna get 8.5 squared, right? And that comes out to be 72.25, and this would be square miles, okay, or miles squared. We read it square miles even though we write it as miles to the second power. Okay, well, hey, rectangles, all right? We know that if we want to count the number of squares in a rectangle, whatever the dimensions of that rectangle are, we don't need to count every single rectangle, okay? We just need to take width times length, and we have length times width, all right? We can also say base times height. Sometimes we say that, which will apply next, all right? So length times width. Hey, try these couple, pause it real quickly and see if you can find the areas of these two, all right? Write those down real quickly and then check it out. You get 45.24 square miles. Not too tough, huh? How about B here? Got an X. Your answer's going to have an X. If you haven't tried it, pause it, try it out. We're going to get 10 times X plus 5, which is just, if we distribute this out, 10X plus 50. All right, no units on this problem. If you want to put units squared, that's fine. Now, another important shape that we don't have here is a parallelogram. A parallelogram is a quadrilateral, has 4 sides, and the opposite sides are parallel. And it turns out, as we probably talked about in class, if you were there, that if we take this little triangle here and move it on over there, we can take any parallelogram and we can change it into a rectangle. In other words, the area of this red parallelogram is going to be equal to this blue rectangle, all right? If we have this blue area right here, all right? So that blue area, that rectangle is just length times width, right? Or in this case, we're going to call this height, and we're going to call this the base. Okay, base is always going to be one of the two sides, and the height is going to be the distance between those two bases. All right, so so again, base can be, you pick a base, doesn't matter, this base and that base, all right, they're the same, and so the height is the distance between them. So the area of a parallelogram is base times height, all right? So if we had a parallelogram like this, and we know that this is 12, and we know this distance here is 3, then the area is 3 times 12. Okay, and this has to be perpendicular distance, by the way. Okay, 36. Maybe we'll say square units. Now, if we take a rectangle and cut it in half, we get a nice right triangle. So a rectangle we saw has an area of base times height. That's for this rectangle here. Now, if we cut it in half, we draw on this diagonal right across here. Okay, we get a triangle. Now, more specifically, we can say any triangle can be shown to be exactly half of a parallelogram. If I take this blue triangle, kind of a squiggly line there, okay, this blue triangle, and I were to make an exact copy of it, I would get, and I attach it to itself, I would get a parallelogram. So we can see that any triangle is half of a parallelogram. So the area is 1/2 of base times height. So if we have a base B and height H, a triangle is 1/2 B times H. Okay, now the base and height always have to be perpendicular to each other. Okay, so area equals 1/2 times the base, 4, and the height, 5. Okay, so if it's a right triangle, that's not too tough. 1/2 times 20, and that is 10. And the units would be square centimeters. Why don't you try the next one over here? Hit pause and try that out. So we get 1/2 times 10 times 48, which is a half times 10 times 48, 4.8, sorry, is 48, which is 24, and that would be square inches. So finally, the area of a circle, well, first of all, the circumference, we've got to review that. The distance around a circle, if you start here and you want to go all the way around, that distance around is pi times farther than the diameter. So the circumference is pi times the diameter. So that's what pi is. Pi is just the number of the ratio, I should say, the ratio of the circumference to the diameter. How many times farther is it around a circle than across? That's what pi is. All right? So it turns out that when we want to find the area, as we proved in class, the area is going to be pi times the radius squared. All right? So why don't you try these? Now, you don't know the radius. You got to find the radius. Pause and try these real quickly. Find them exactly. Find the exact answer, and then find a decimal answer, and use a pi key on your calculator. Okay? Find the radius first, and then find the exact answer. Here, I'll do the first one. Pi times 8 squared. Okay, 8 squared is 64, so we say 64 pi square yards. Okay, there's the answer exactly. We call that an exact answer. Now, you go to your calculator and you can punch in 64 times pi. You'll get a big old long answer, 201.06192983. We'll round it off to maybe 1 or 2 decimal places. that's the idea. Try the next one real quickly there, and we'll wrap this up. Make sure you find that radius first, right? Okay, so area equals half of 5.4 is, 2.7 squared. So 2.7 squared is 7.29 pi. So that would be the exact answer. And if we go ahead and multiply that times pi, we get, busting out the calculator here, we get 22.902. Okay, or 22.90 square yards. That's the idea. So there's the approximate. Really, we should put, approximate, or the squiggly equal signs here. Put some there too. Okay, so we should have approximate. Okay, because that's rounded off. Once you round it off, it's not an exact answer. These are approximate. These ones are exact. Well, we'll stop there for now. We're going to talk about sectors there tomorrow, and we'll call that good. A good review there on area.